Module 3 focuses on measuring disease. Statistics are used to summarize the data collected through epidemiological studies, so we can learn from the data. Quantifying the occurrence of disease helps us to describe risk, make comparisons between populations and among groups, identify high-risk groups, and generate hypotheses about the causes of disease. Ultimately, these hypotheses may be tested through analytical studies, and if causal factors are found, prevention and control measures may also be identified. Counting cases and comparing their characteristics is the most basic measure of disease frequency and the easiest to compute. There are three kinds of frequency measures used with dichotomous variables. Dichotomous means two-level, like present or absent, yes or no, and variables may refer to any characteristics under study. These frequency measures are ratios, proportions, and rates. We use a ratio to compare two independent groups, a proportion to compare one group with a larger one to which it belongs, and a rate to measure an event in a population over time. Ratios, proportions, and rates are used in epidemiology to describe morbidity, that is disease, and mortality, death. Before we focus on specific measures, it's important to understand the relationship between the three types of measures and how they differ. All three measures are based on the same formula of x over y multiplied by the rate base. In this formula, x and y are the two quantities that are being compared. The formula shows that x is divided by y. If you're not familiar with the nomenclature of 10 superscript n, it's simply a shorthand way to say how many zeros the number has. So 10 superscript 2 would be 100 and 10 superscript 5 would be 100,000. This so-called rate base is a constant that we can use to transform the results of the division into a meaningful quantity. Several standard measures are used to measure and describe the frequency of disease. Each measure has its appropriate uses depending on the situation and the information available to the epidemiologist. The two main types of rates are incidence and prevalence. The four types of incident rates are incident rate, person-time incident rate, attack rate, and secondary attack rate. We'll not discuss the latter two in this presentation as they're discussed in the course text and will be referred to in a later module on outbreaks. The two types of prevalence are point and period prevalence. Incidence rates are the most common way of measuring and comparing the frequency of disease in populations. Incidence deals with what is new and as such is a measure of risk of developing the disease. The formula for calculating an incidence rate is the number of new cases of disease that developed in the population at risk during a specified time interval. To illustrate this, in 2007 there was 23,231 new cases of prostate cancer in Canada, and the male population was almost 15.5 million. So referring to the formula for incidence, the numerator x includes only the new cases of the disease that occurred during that year, and does not include cases that occurred or were diagnosed earlier. This is very important when working with chronic diseases such as prostate cancer. The denominator y is the population at risk. This means that the people included in the denominator should be able to develop the disease in question during the time period covered. This is why we only include males, as females do not have a prostate and therefore are not at risk for developing the disease. The denominator should also represent the population for which the cases in the numerator arose. The population may be defined by geographic area, as in this case Canada, or could be by membership in a specific group, such as employees in a company. In practice, the size of the population is taken at the midpoint of the specified time period. Commonly, this information is obtained from census data, but if you're studying a specific group, such as students in a school or residents in a long-term care facility, you should use a census of that population for an exact denominator. Any value of n may be used in calculating incidence. Regardless, you should always make it clear what n value was used. In this example, a value of 10 superscript 5 or 100,000. A good rule of thumb is to choose a value for n so that the smallest rate calculated is a whole number. This is just easier for others to understand. When comparing two incidence rates, always be sure that the same value of M was used in calculating both rates. Disease incidence rates imply a change over time, from health to disease, so the period of time must be specified. For surveillance purposes, this is usually 1 calendar year, but any time period may be used in incidence as long as it's stated. So what happens when the sum of time at risk of developing disease varies amongst the persons included in the denominator? The person-time incidence rate can be used. This is the rate at which new events are occurring in a population. The formula is as follows. The numerator is the same as for the incidence rate, but the denominator is the total person time at risk, and this is computed by summing each individual's time at risk. So if we use an observational study describing the incidence of prostate cancer as an example, so that 1,000 men who are free of prostate cancer are enrolled and followed for 4 years. In the first year of the study, 10 new cases of prostate cancer are diagnosed. In the second year, 15 additional cases, 20 in the third year and 25 in the fourth year, for a total number of cases of 70 over the 4 years. Using the previous formula for the incidence rate and the size of the population at the midpoint of the study, the risk of developing prostate cancer over the 4 years of the study is 70 divided by 975, expressed with a rate base of 100, so 7.2 per 100 persons. To calculate the person time incidence, you need to calculate the total time that each of the 1,000 men were at risk. So for example, subject A died from another cause midway through the study, so was at risk for only 2 years. Subject B and D completed the study, so were at risk for 4 years each. Subjects C and E were diagnosed with prostate cancer in the final year of the study, so were no longer at risk for developing the disease, so were only at risk for 3.5 and 3 years respectively. This process is completed for all 1,000 male subjects, resulting in a total time at risk of 3,920 person years, giving an incidence rate of 1.8 per 100 person years. To recap, the person time incidence rate measures rates at which disease is occurring in a population. It has the advantage of accounting for loss of subjects, permitting staggered entry into the study, and more accurate estimates of rates, as incomplete information is often a problem associated with the calculation of the incidence rate. Prevalence is the proportion of people in a population who have a particular disease at a specified point in time, or over a specified period of time. The numerator includes not only new cases, but also old cases. A case is counted in prevalence until death or recovery occurs. This makes prevalence different from incidence, which includes only new cases in the numerator. Prevalence is most useful for measuring the burden of chronic diseases. The amount of disease present in a population changes over time. Sometimes we want to know how much of a particular disease is present in a population at a single point in time, a sort of snapshot view. This is termed point prevalence. At other times, we want to know how much of a particular disease is present in a population over a longer period. We would use period prevalence to do that. Period prevalence is calculated in exactly the same way as point prevalence, except the numerator is the number of people who had the disease at any time during a specified time period. Period prevalence can be calculated for a week, month, year, decade, or any other specified length of time. Prevalence may be compared among different diseases or different populations as long as the length of time is the same. The relationship between incidence and prevalence depends on how long the disease persists before cure or death, and can be illustrated diagrammatically by this water basin. Incidence is depicted by water flowing into the basin. Prevalence is represented by the water level in the basin. When the inflow is heavy, that is, incidence is high, the basin fills up. However, the water level, that is prevalence, is also influenced by the amount of water draining from the basin. The draining water represents the resolution of the disease either through death or recovery. So if the disease resolves quickly, the prevalence will fall unless balanced by the inflow of new cases. This relationship of prevalence, approximating the incidence multiplied by duration of disease, is true in what is called a stationary population, and the prevalence of disease is low, less than 10%. Incidence and prevalence measure the frequency of disease. Mortality rates measure the frequency of occurrence of death in a defined population during a specified interval. To calculate a mortality rate, we need to know the number of deaths in a given population during a specified time period and the size of the population in which the deaths occurred. The crude mortality rate is the mortality rate from all causes of death. The cause-specific mortality rate is the mortality rate from a specified cause. So, for example, the crude death rate in Canada is 7.2 deaths per 1,000 population, and the cause-specific mortality rate for prostate cancer is 18 per 100,000 males. This lecture has provided an overview of the most commonly used epidemiologic frequency measures, namely incidence, prevalence, and mortality rates. Chapter 6 in the course text describes many other general health and population indicators. Different measures of health capture different things and can give a very different picture of the health of the population.